Good morning, good afternoon, good evening, good whatever time it is, wherever you are in this amazing planet of ours. I am Malcolm Hawker. I'm the host of the CDO Matters podcast and also the CDO of Prophecy. If you don't know about Prophecy, check us out. We make some amazing MDM software. But that's not why we're here today. We're here today to talk to Mr. Alberto Pan. He's the CTO of Denodo. And we're going to talk all about what I'm just calling loosely modern data architectures. We're going to focus on the data estate, building a data foundation, building a modern data ecosystem. So we're going to get into a bunch of different topics today. Maybe we'll talk a little bit about fabric. Maybe we'll talk a little bit about lake houses and swamps and warehouses and where things are going there. Can't have a data-related podcast these days without maybe talking a little bit about AI. Maybe just a little bit. Hopefully that's grabbing your interest. Alberto, so nice to see you. Glad for you to join today.
Thank you, Malcolm. Nice to see you. Thanks for having me.
You're very welcome. Are you in Spain right now?
Yes, because actually Denodo is a US company, but actually the origins of the company are in Spain. Actually in the northwest of Spain, in Galicia. I don't know if you are familiar with the geography of Spain. And actually, most of the research and development team is still based here. So okay. I'm also based here in Spain. Yeah,
I'm kind of familiar with your part of the world. I like to do photography, and I watch a lot of landscape photography things on YouTube. And there's some amazing coastline where you are. I've heard the coastline looks just brilliant with rocks and cliffs. Yeah, it looks brilliant.
Yeah, actually, it's called the Coast of Death because
okay. I shouldn't be laughing about the Coast of Death, but okay, it doesn't sound like a place where you want to go vacation.
Yeah. No, it's a fantastic place actually for going on vacation. But it was not such great, if you were in a ship in the middle of a storm.
Okay.
Because the coast is really, really rocky. So it can be quite dangerous for ships, but it's amazing for people and a very, very beautiful place.
Okay. So it's the Coast of Death if you're in a boat with poor navigation or poor propulsion. But for vacations, it's wonderful. Okay. That's good. It's good to know that. Let's talk a little bit first about data virtualization. Let's assume that I'm a newer CDO or I'm a newer data leader. Maybe I've been promoted out of a business position. Maybe I'm somebody that is now responsible for data and analytics practice or defining some governance policies, but I've come out maybe of a business position. And I'm looking at all the technologies and I'm overwhelmed, man, because there's a lot of stuff out there and there's a lot of buzzwords. Help that new CDO understand what data virtualization is. How is that different than like data integration? Why is data virtualization an important part of a modern data ecosystem?
Well, yes. Data virtualization basically allows you to create a logical data layer on top of multiple distributed data sources. So if you have data distributed in multiple data sources and you want to combine that data and expose them in the language of the business maybe for creating reports, creating data products, or for exposing the data in the shape that a certain application needs. Data virtualization basically allows you to do that, allows you to create these virtual views that will appear to your consuming applications as virtual tables, as if they were accessing a database. But actually, behind the scenes, the engine is going initially in real time to the data sources to get the data that is needed to answer each question, each one of the queries, and return it to the consuming applications in the appropriate form. So it's a way of virtual data integration, let's see, because you don't need to move the data to a central system before starting to query it.
Okay, so how is that different than a semantic layer, or are they different?
Actually, it's conceptually speaking, is very, very similar to a semantic layer, right? I would say that it's a particular type of semantic layer. For instance, in this case, typically the metaphor that we use to expose the data is relational. So basically, you are accessing virtual tables. And those virtual tables, as you say, are combining data from several data sources and are exposing that using different naming conventions, using typically, the language of the business. So to that respect, it's very similar to a semantic layer. But for instance, other semantic layers, for instance, tend to use a multidimensional model to expose the data. In this case, is typically relational. But in a nutshell, the idea is very similar: to hide the complexity of the data landscape, also to allow the data landscape evolve without affecting in any way the data consumers that always get this consistent view of the data in the language of the business.
Okay, that's helpful. So let me summarize, if I may, and keep me honest. So it is a logical layer that allows you to, in essence, virtually break data silos by having a single place to go to get data for maybe a common object, like a customer, right?
Yes.
And maybe customer table 1, table 2, table 3, table 20. You've got 20 tables of customer data, but you want one place to go get it. How does a virtualization layer handle the fact that it's customer over here and it's account over here and it's person over here? Is there a management layer there that allows you to kind of virtually map those together? How do those things get linked?
Yes, data virtualization software like Denodo has this type of, let's say, data integration and mapping functionalities.
Okay.
You can also, of course, leverage specialized systems like NDM systems, like Proficy, that in many cases have already created like this, let's say, well-curated and with high data quality views of key business entities. And then we can also combine that with all the additional data sources, for instance, with transactional data, or for data coming from SaaS applications, or for data coming from external APIs to, let's say, further enrich the information about those key data entities to fit the needs of specific business use cases. So in summary, yes, on one hand, data virtualization includes data integration capabilities to perform this type of matching, of matchings, mappings, and so on. But we can also leverage specialized systems. And then in that case, you can simply put data virtualization on top of that, and it will provide a unified view over this NDM system and all the other systems that you may have in your organization.
Okay, but I assume this is all read. Like this is all reading databases. Does it support write or how does that work?
It also supports write when the data source also supports writes, right? Okay. So for instance, if your data source is a database, you will be also able to write to the database. But for instance, in many cases, it happens that, for instance, maybe your data source is an API or a software as a service application, and maybe those operations are not allowed. And also, when you are creating unified views, it's the same like writing in a view in a database. Some views cannot be updated. It depends on the definition of the view. But when the data source can be updated and your definition of the view also allows that, then yes, data virtualization will allow you to write back to the data sources.
Okay, so what are you persisting in this logical layer? Are you persisting just links back to the source? In essence, are you, and I know this is going to sound like a drastic oversimplification, but are in essence you managing kind of a lookup table, as it were, that points back down to all those various sources? Or are you actually persisting chunks of the data itself? I suspect the answer is no on the latter, correct?
By default, all the access to the data is done in real time. But actually, we include many functionalities also for caching, for many types of caching, right? It may be, for instance, maybe you want to materialize or to cache the data of this particular data source, but not the data from this other data source. Or maybe you want to cache only the data that is accessed more frequently. Or maybe you want to have pre-aggregated caches, like materialized views, the idea like materialized views. So for instance, when you are computing aggregates, you don't need to start from scratch for every query. So let's say by default, yes, by default access is in real time. We have a really sophisticated query optimizer that rewrites the user queries in such a way that we maximize query push down to the data sources and minimize network traffic, so you don't need to, to bring a lot of data through the network. But we also complement that with these advanced caching functionalities that are transparent to the user. Actually, we are even able to use AI to automatically select the best caching strategies for each use case. So yeah, behind the scenes, there is also some partial copying of the data. Okay. But from the point of view of the user, this is pretty much transparent.
Got it. Okay. So where would this virtualization layer kind of physically sit within the architecture, or maybe logically sit, and not necessarily physically sit? Is it something between the source applications and a data warehouse, or is it generally something kind of sitting beside the data warehouse? Where do these things fit together?
Typically, the most typical pattern, data virtualization works on top of the analytics data sources. So for instance, works on top of maybe one or several data warehouses, one or several data lakes, ODS data marts, and so on. So it's like the logical layer between the analytical data sources and then the analytical applications. For instance, I would say the most typical consumer of the Denodo views may be Power BI, right? Or this type of BI tools. It's only a particular example, right? Also data science tools, also custom applications, right? But typically, the most typical pattern is where Denodo provides, or data virtualization provides, this unified analytic view. Gartner, for instance, called this the logical data warehouse, right?
Yeah.
So you have multiple analytic systems that are specialized for different analytic needs. Because as you know, in modern organizations, in big organizations today, the data needs are very diverse. In most cases, you are not able to attend all your data needs with a single system in an optimal way. So in a natural way, it happens that in big organizations, at the end of the day, you have different repositories. Maybe some of them are on premises, some of them are in different cloud providers. Maybe one of them is more specialized in data science use cases, another one more in business intelligence use cases. Data virtualization provides like the unified semantic layer or the unified business data layer on top of that, where you can abstract the consumers from where the data is really coming from, and also you have a place to apply a single entry point to apply consistent security and governance policies.
Got it. Okay. So I'm having some flashbacks to my time at Gartner when we first started talking about the fabric, and there were a number of analysts that were saying, well, how is this different than the logical data warehouse? We'll talk about that, because I'd like to answer that question and get into it a little bit. But I do want to tie off on some of the common use cases of where this is useful. I think you mentioned a few. I have to imagine that your customers tend to be fairly large organizations with potentially multiple databases, multiple warehouses, lots of mergers and acquisitions where new data sources are getting added all of the time, and it's more effective or efficient to virtually connect them than to physically connect them. Does that sound correct?
Absolutely correct. Also, in this type of organizations, the typical architecture of having to centralize all the data is very hard in this type of organization, right? For many reasons. Sometimes it may be for technical reasons, because moving the data from some systems to a central repository may be hard, but it may also be for legal reasons. Maybe some data cannot be moved outside of a certain geographical region, or for organizational reasons, right? Because, different business units in many cases want to retain ownership of the data, right? So, and also, as I mentioned before, because the analytic needs in these organizations are very diverse. So it's very, very hard to have one single system that is the most optimal in performance, functionality, and cost for all your needs. That's very, very hard in big organizations. So that's where this abstraction layer basically allows you to let's say use the best system for each use case, while still having this consistent data access layer and this consistent security and governance layer for delivering the data. So that's really Denodo's sweet spot.
Got it. let's talk a little bit about the idea of kind of centralization versus decentralization. There's a lot of the conferences I'm going to these days. There seems to be this rebellion against what people call, centralized patterns of anything. Is it correct to assume that an enterprise class virtualization layer could support domain-driven design, could support the idea of this domain having this rules and this domain having these set of rules and this domain having that set of rules? Is that a pattern you see?
Yes. As you know, in the last few years, we have heard a lot about this type of decentralized management patterns. Probably the most radical way of doing this would be the data mesh. But we can also have like mixed patterns, right? Because probably not every organization is ready to go with the data mesh, on day one. But certainly, a big problem with centralization are bottlenecks, right? Not only centralization from the technical standpoint of needing to use a single system for everything. Also, having a single team in charge of everything, that creates a lot of bottlenecks, right? And you also know what happens with bottlenecks when the business in many cases cannot wait. So if you are spending weeks in delivering the data that is needed for a certain business need, then, I think it's very likely that the business will find a way to get the data anyway, going around your system. And then at that point, you don't even have the benefits of a centralized system because you don't even have unified governance anymore or unified security anymore. You are creating shadow IT, right? And that's why I think these patterns like the data fabric that provide you flexibility for decentralization. That does not mean that you need to go full decentralization because, it depends on the organization and it's also clear and obvious that in many cases, consolidation, trying to consolidate certain systems is a good idea, but you should not be forced to always consolidate everything in the same place. That's very, very rigid and very hard to sustain in time, I think, for a big organization.
Yeah, I fully and completely agree. I mean, the right answer almost always seems to be a hybrid approach with a certain degree of centralization, a certain degree of federation or decentralization. Because the fact remains, and I'm getting on a little bit one of my soapboxes here, is the fact remains is that there are centralized uses of data that occur at higher levels. The C-level wants to see things a certain way, and they've got their definitions, and functional levels have their definitions, and they can both be correct. So I'm anything that is either centralized or fully decentralized, generally the case that I'm making is both. One thing to keep in mind, I did actually have a podcast. I was trying to find the episode number. I'll look it up here in a minute. I did have a podcast a few months ago where I went into the differences between MDM and a semantic layer. So we won't cover those here. I'd invite you to go check out that other podcast that I did, CDO Matters. I will say the episode here in a little bit, but where I go into detail around the difference between an MDM system and a semantic layer, or what we're talking about here is a data virtualization layer, largely operating the same way. The key difference that I would say is that MDM operates at an individual record level, right? You can actually, it will master and manage and link and merge at a record level where the rules can get very, very, very specific into how you actually link an account to a customer or link a party to an account to a customer record. The rules are very granular. There's data stewardship. There's workflow component to it. Anyway, check out that previous episode, MDMs versus semantic layers. If you've got some questions, if you were listening to Alberto talk and you're saying, wait a minute, that sounds a little bit like MDM. There's certainly some overlap. There's certainly some, but guys, that's not uncommon in the world of data management. There's overlap between MDM, virtualization layers, integration layers, data quality tools, data governance tools. If overlap makes you uncomfortable, well, then this world will probably cause you a little bit of discomfort because there's certainly a certain degree of overlap in all of these tools. Let's double back, Alberto, to the conversation about the logical data warehouse and the fabric. Again, I'm a newer CDO. I may not have a ton of technical background. I'm hearing a lot of buzz about a fabric, and this idea of a logical data warehouse makes sense. That what you described, I get that. help me better understand if there's a difference between that and a fabric, or are they synonymous? Yes or no?
They are not synonyms, but I typically say that the data fabric is the logical data warehouse on steroids. Meaning that the data fabric shares with the logical data warehouse this idea of, okay, you will have multiple distributed sources specialized in different tasks. You want to provide a consistent view on that, view overall that in the language of the business that is stable. That's common with the logical data warehouse. And then on top of that, data fabric, I think, well, there are a couple of things that it adds, but probably the main one is AI and metadata, and being metadata driven, right? This idea of, okay, I will collect all type of active metadata, like for instance, who is using what data products, when and how. Also, I don't know, bottlenecks or what data sources are typically used together. And I will use all that to add intelligence to the architecture, right? And this may mean, for instance, intelligence in terms of FinOps, for instance. So the system is able to automatically, for instance, suggest where you should move this particular workload to optimize your cost. Or maybe when you are creating data products, you use past activity in the system to get automatic recommendations about how to combine data or things like that, right? So I would say that's one of the key differences. Another key difference, I think, is also the idea of catalog or marketplace. So I would say that in general, the fabric is much more, let's say, data product oriented, while the logical data warehouse maybe was more, more focused specifically on data integration, while the addition, on top of data integration, to actually create data products, you need a lot of metadata, right? About a lot of data about how this should be used, what are the required levels of data quality. You also need an infrastructure to discover data products, right? So that's one thing that the fabric puts on top of the logical data warehouse. And the other key one is this automation and use of AI based on the active metadata. So yeah, it's very, very similar. The concept is very similar, but I would say is it incorporates more advanced concepts, right?
Yeah, for sure. I love that definition. The data virtualization, the logical data warehouse on steroids. But I'd even go a little bit farther. I mean, in at least in Microsoft's version of the fabric, you can spin up Spark jobs, you can spin up data pipelines. There's a lot of things that you can do in there that I would never expect a virtualization layer to handle. So maybe one way to think about it was that, in Gartner's, this is just Gartner's view, but in their original view of the data fabric, a critical enabling capability was data virtualization, right? The ability to get data from anywhere across a very diverse ecosystem. One of the layers in the fabric was, and is, I would argue, just this logical data warehouse. Then on top of that, at least what Microsoft is doing is layering a whole bunch of other capabilities, including data governance, including metadata management, like you were talking about, including even MDM. Prophecy just released a native fabric workload where you could actually instantiate and create an MDM workflow from within Fabric. So great way to say it. It's a lot of things on steroids, but I wouldn't be confused if a lot of people have or wouldn't be confused. I wouldn't be surprised if people have some confusion around what the fabric is, because it touches on a lot of different pieces.
Yeah, absolutely. And it's also true that sometimes, different vendors use the terms slightly different.
Yes.
Probably the concept of fabric in Microsoft, I would say it's not exactly probably the original concept from Gartner. It's slightly different. But yeah, totally agree that I think one key idea in fabric is this idea of complete platform, right?
Yeah.
And that means a lot of things. That, for instance, means obviously some of the things that you mentioned, right? Like, for instance, not only logical access to the data, also the ability to quickly spin a new system that is able to that you can use on the fly to process data for a certain specific need and so on. So yeah, it has this idea of being a more comprehensive platform. but many of the key concepts are still common.
Yeah, and you're absolutely right. So the way that Microsoft is describing a fabric today is very different than Gartner's original version of a fabric, which goes way farther. So Gartner's original version for that fabric did get into the use of metadata to automate data governance, data management, even to get into when you start to leverage in AI and Gen AI, to get into things like automating, like building pipelines, automating of mapping of elements between source and target, all of that stuff. That's cool. That's cool. But there is an enabling component there of this logical data warehouse that is critical and has to be there. So yeah, it's, boy, if I was new to this world, and there's so many technologies out there and there's so many buzzwords, just cutting through that stuff would be trying to figure it all out would be a months long enterprise. Let's talk a little bit about data products. You mentioned those previously. Now, you are not a data marketplace per se, but I can see how this logical data warehouse would play a critical role in helping you support a data product strategy. Tell us more. Where do you fit?
Yeah, well, at the end of the day, basically, a data product is a way to expose data in a way that can be easily used and also easily reused, right? To create other data products, and guaranteeing also like a common management of all these data products that maybe are being created by several things, by several independent things. So if you think about it, that's exactly what, in many cases, what data virtualization does, right? With data virtualization, you can create, let's say, business-friendly views of data that is in any data source. Also, by the way it works, it's very natural to reuse data products, because actually in data virtualization, typically you have a layer architecture of components where one component is defined using other components. So that provides a very, very natural way of doing reuse. Also supports very naturally the things that you need to ensure interoperability between data products, right? Other thing that you typically want is, okay, if I am creating a data product that provides customer data and you are creating another data product that also provides customer data enriched with other information, you want those two data products to use consistent semantics, and also you want them to be able to interoperate. In data virtualization, you have, for instance, the concept of top-down modeling that basically means is what we would call today contract-based development. So basically, when you are creating a data product, you can enforce contracts for the data products. So basically, it allows you to have multiple things that are creating data products using their own systems. They don't need to use the same system for everything, but at the same time, you are able to guarantee consistent semantics, also to provide a way of reusing components, and also a way to enforce consistent security rules, security and governance rules. So it's one of our most typical use cases today.
So that last bit, when you started to talk about contracts and enforcement of data governance and data security rules, that last bit I think is really important, because today what I see with a lot of data catalogs is that the catalogs may be documenting all the metadata. They may be documenting, this field is this wide, this is an integer, this is a varchar. Like they may be documenting the components of what could be in a data contract, but they may not necessarily be enforcing them at runtime. If that makes sense. What you described is that if I'm running a query, and if I just want to execute an API, hit some API, at the point of execution, you can enforce those rules, which is a really important component here, because for so many data management systems out there, they're not actually enforcing governance policies. They may just actually be defining them. That's interesting.
Yeah. I think one problem with traditional catalogs is that, right? Especially in big organizations, it's very easy that they get a little disconnected from reality. So what you see in the catalog is not always what you see in reality. So actually, I think one key idea of the fabric, of the data fabric as originally defined by Gartner, was also removing that mismatch, right? Let's say that the the place where you define the policies should also be the place where the policies are enforced. So that means at the end of the day that you need this common layer, this common access layer. So the policies are enforced there, right? I think this is a really, really powerful idea that actually has a drastic impact. Because sometimes when you talk about this data fabric or logical data warehouse or logical architectures, we focus too much on maybe on the data integration part, but I think this part is probably the one that provides the clearest benefits, right? When the policies that you define there, by definition, will be applied, right? Also, if you are in a distributed environment, if you have multiple things creating data products, you can also use the idea of federated governance, meaning that, okay, yes, you are creating data products with the data in your system, and you even have the freedom to decide who can access your data products. But at the same time, I am able to enforce policies that will apply to all data products, for instance, because of regulations or whatever. For instance, here in Europe with GDPR or GDPR policies or whatever, right? So this idea of, okay, you have the freedom to use your system, to have the data in your systems, you design your products with a lot of autonomy, but at the same time, the policies that I have established are not only in paper or in a static catalog. I can guarantee that they will be applied. I think that's really powerful.
I totally agree, and I would strongly advise all the CDOs out there that if you're looking at data governance software, including a data catalog, ask the question of how is this used to enforce the rules? And I think what you will find is that the answer will typically be, well, those rules are enforced within the operational systems that are managing that data, right? The rules are enforced in a CRM, or their rules are enforced in Power BI about who can log into Power BI. But that may not be enough, right? So what you're hearing Alberto say here is that you can enforce at runtime who can see this, who can do this. You can set up these contracts which have create a structured relationship between producer and consumer data. I love it. All right, Alberto, in our last few minutes, let's talk a little bit of course, about the thing everybody's talking about. Let's talk about AI. But I don't think we need to talk necessarily about how a logical data warehouse would enable the use of AI, because I think to me that's kind of slightly self-evident, right? If you're creating a single place where you can run a machine learning process, some sort of Spark process against that data to go run an algorithm, do anything. I'm a little more interested to understand what you see, where you see things headed from the use of AI within products like a Denodo and others that you compete with. What do you see over the next few months and years? Where do you see AI kind of helping to augment or automate some of the management and processes that these logical data warehouses support?
Well, for instance, in development, I think we will see in the development stage, for instance, when creating integration pipelines or when defining virtual views or data products or whatever, I think the new models that are starting to appear that are not pure large language models. I am thinking, for instance, in O1 now, R1 DeepSeek, that is the model of the week, right?
Yes. Of the week, exactly. Yes.
Exactly, and that I think these models are starting to get really good at all the flavors of code generation. And that includes SQL generation or the languages that you use to define pipelines, right? Python generation and so on. So I think, obviously, this is already happening. All data management products are already incorporating some type of AI assistant that helps you to, at certain stages of the development process. But I think like in 2025, we will see a big jump, right? It's like the assistants so far have been restricted to relatively small things, or I don't know, some types of restricted automatic suggestions. I think in 2025 and maybe also the first half of 2026, because as you know, it takes time to get this into the products, we will see a clear jump. I think these models are getting really good at this type of particular tasks. That maybe, the older generation, the GPTs and so on, were also good, were also useful, but maybe still not that good as I think this new generation is going to be. And obviously also in all that is related to data democratization, that will be obviously important. For instance, in data management, every user interface now also includes a natural language interface, and the quality keeps improving. And also it's getting easier and easier to fine-tune models and even to have your local models. Again, DeepSeek may be another example. And that means that you will be able to customize them more, and that means that will be more effective for your particular use cases and your organizations, and it will be more and more reliable. So again, that's something that we are already seeing today, but I think it will accelerate, right? It will accelerate this year and next year. And I think the change will be quite evident.
Yeah, I couldn't agree more. I just spent the weekend in Austin, Texas at Data Day Texas and listening to a bunch of presentations over the last couple of days with the complexity of these RAG patterns and the complexity of the patterns of being used to fine tune and iterate and fast iterate on the tuning process. My mind was just like, graph RAG, dogs, DAGs, hey, all of these patterns. And, what I saw was the evolution of a really, really powerful, I don't know how to describe it, maybe like middleware. I don't even know if that's the right word, but where there's software that is being used to create these prompts that are incredibly powerful to do things like what you just described, right? Like write me a Python job that will go get my customer data from all of these sources and present it back in this format. Really, really, really powerful stuff. So, well, on that note, AI, it's out there. It's coming. Yeah, the DeepSeek, that's the flavor of the week. But we're recording this, late January. When it publishes in February, who knows what the next what the next flavor will be. Yeah. But I want to thank you, Alberto. This has been wonderful. I learned a lot about data virtualization and logical data warehouses today. By the way, folks, if you're still with us, episode 54. I had a great conversation with Sanjeev Mohan, super, super smart guy around semantic layers and understanding what the differences are, talking a little bit more about them versus MDM. So check that out. Thank you so much, Alberto.
Thank you, Malcolm. It's been a pleasure.
All right. With that, I will bid everybody adieu. Thank you for tuning in. Thank you for watching on YouTube. Thank you for downloading through Spotify or Google or wherever you get your podcasts. If you haven't already, please consider subscribing to the podcast. That would be an absolute thrill. I will see everybody again in another episode of CDO Matters sometime very soon. Thanks all. Bye for now.